One trouble with creating a project on Keil that uses only assembly code is that arrays cannot be written. When we create a project that only uses assembly code on Keil, if we create an array in our program, the array is loaded straight into the flash memory. This becomes an issue when we try to write to the array. To fix this, we simply copy the array from flash to RAM. Once the array is in the RAM, we will have no issues writing to the array. I attached a template that fixes this trouble and lets us write to an array. Today I will show you how to create a project on Keil that uses only assembly code and lets you write to an array. We will start by creating a new folder, and we will name it Writing to Array. Now let's open Keil. Click on the top where it says Project and create a new project. Locate the folder we created in the beginning. Save your project inside that folder. Name it the same name as the folder, Writing to an Array. Now Keil will ask you to select a device. For this project, we will be using an ARM device in the Cortex-M line. Once we select it, click OK. A pop-up will show up. We can safely ignore it by clicking OK. Now click the plus sign on target and right-click source group, then click Add a new file. Click on ASM, then name it main, and click Add, now that our S file is created. Right-click on target, then click Options for target. Move over to the Debug tab and click Simulate, and uncheck Run to main. Now locate the text file and copy it straight into Keil. Click Build. We get 0 errors and 0 warnings. Now click Debug on the top and start a debug session. Now step through the code. It will run line by line. Now let's type the address of the array into the memory window. Locate the Memory 1 tab on the bottom right and type 0x2, then 7 zeros into the address. This will show us all the 3 elements in the array. Now let's test if we can write to the array. This highlighted code I added to very bottom of the program. It will load the address of the array into R1. Then we will write 5 to every element in the array. Doing this code will update the elements in the original array to the value I entered here. Now let's run it. Click on Build to ensure we get 0 errors and 0 warnings, then click on the Debug tab on the top and start a debug session once again. But before we step through the code, I typed the address of the array into the memory window in Memory 1. I typed 0x2, then 7 zeros. Now we will be able to see in real time what is happening to the array when we step through the code. Now, by stepping into our code, we will see our array start at 0, then get updated to the values shown. We originally loaded these values at the start. These are all the elements in our array. Now let's continue to step through our code. Now we just stepped into the line where we wrote to element 1. Here is the updated value in the memory window. When we step through a second time, we will see the second element change as well. And if we step through a third time, we will see the third element in our array changes to the value we wrote to it. This means we wrote to an array.